Well, how are you doing? This video is going to be called Complementary Angles. And it's based around claims made by our opposition, mainly a man named Prototad. That's his YouTube his Discord avatar name. This man created this diagram and he is making some claims. I have had a good bit of interaction in the comment section on YouTube with this man. So rather than continuing that on, I'm just going to make this video. I will be addressing this diagram here, which is his diagram and his claim at the end, or his main claim, I should say, at the end. But I will be addressing some of his other claims and some stuff just before that first, okay? Okay, first of all, the first thing I'm going to do is I'm going to address some straw man arguments that are being used against us, the flat earthers, against our side by our opposition, right? So, start at the start. Straw man 1. The first straw man is that we, as in flat earthers, claim that celestial navigation use right-angled triangles to create circles of equal altitude on the surface of the earth. No, celestial navigation claim and prove that they use right-angled triangles in creation of circles of equal altitude on the surface of the earth. Flat earthers just relay this information via official sources. That's straw man 1. So that is not us, that is celestial navigation. Straw man 2, that we, as in flat earthers, claim that celestial navigation triangulate their position at sea using right-angled triangles and circles of equal altitude. No, celestial navigation claim and prove that they triangulate their position at sea using right-angled triangles and circles of equal altitude. Flat earthers just relay this information via official sources. Straw man 3, that we, as in flat earthers, claim that arc does not refer to the sky or the earth, but rather it only refers to the arc within the sextant itself. No, celestial navigation claim that arc does not refer to the sky or the earth, but rather it only refers to the arc within the sextant itself. Flat earthers just relay this information via official sources. And straw man 4, that flat earthers claim that celestial navigation are using terrestrial trigonometry to navigate the Earth's oceans via the use of a sextant. No, flat earthers relay that celestial navigation claim and prove that they use celestial triangulation to navigate the Earth's oceans and not terrestrial trigonometry. These are claims of celestial navigation and not flat earthers. So these 4, and there's other straw man arguments being sent our direction. These 4 straw man arguments keep on being put to us. And unfortunately, the main topic, or the main protagonist that brought me to make this video, Prototad, has made some of these straw man arguments and unfortunately did continue to make them. So, but this is not just him, this is others too. So these are straw man arguments that we don't claim these things. It is not flat earthers claiming these things. We are relaying the information via official sources from celestial navigation websites, books, videos, etc. Not us, celestial navigation. Okay, we'll move on. Okay, claims made by Prototad. Right, this is Prototad, the spearhead of our opposition's fight against the Sextant Argument. Okay, claim 1, that celestial navigation do not use right-angled triangles to navigate their way across the earth, and he backs this up with the claim that there is no mention of right-angled triangles anywhere in any official navigation source material. Okay. The angle measured with the sextant is in reality one corner of a right triangle formed by U, the celestial body and its geographical position on Earth. Okay, this is the first one. Right, I'm going to go to here, I think. See, yeah, the point directly overhead is the zenith. The angle between lines drawn to horizon and zenith is 90 degrees or a right angle. An altitude of 40 degrees, for instance, simply means that the distance from the horizon to the sun is 40 from 90 of the total distance from horizon to zenith. Chapter V1, the sextant. By subtracting the altitude from 90 degrees and changing the result to nautical miles, we should be able to draw a circle of equal altitude around the GP. Sorry, that's not that part I want to see. Anyway, it doesn't matter because it's using 90 degrees, right? Which means that you have to use right triangles. So here we are again, using right triangles. This is all from celestial navigation. So there's 3 different boats, all 3 different distances from this star, all using right triangles. This is from celestial navigation. Here you have right triangles being used by celestial navigation. This is not from flat earthers, this is from celestial navigation. Right triangles. Here we are again, right Earth's surface, the sun, right triangle. We have no end of these references and diagrams and everything else. We have no end of them. All being used by celestial navigation. Okay? So we are not making that claim. We see, maybe see, right. In simplified terms, when we take a sextant altitude of the sun, we are creating a right angled triangle between it, the Earth's surface at the GP, and ourselves. Grade school geometry tells us that the 2 angles in a right angled triangle must equal 90 degrees. So the complement to the altitude projects an angle from the sun onto the surface of the Earth, which, just like in the latitude example above, can be converted to nautical miles. So there you go, right angled triangle. This is official celestial navigation material from their official sources. So Prototat's claim here that there is no mention of right angled triangles anywhere in any official navigation source material is incorrect. Right, it's wrong. Right. Claim 2, that right angled triangles are not used in the creation of circles of equal altitude, and he supports this with the claim that nowhere in celestial navigation literature did it state that right angled triangles are used in the attainment of circles of equal altitude. Okay. Is it this one? No. What? This one. Okay. Right. By subtracting the altitude from 90 degrees and changing the result to nautical miles, we should be able to draw a circle of equal altitude around the GP. Quartermaster 3 and 2. There we are, showing exactly what they're talking about. This is showing a line of position here. But this is the GP, this is the observer. Right. So read it again. By subtracting the altitude from 90 degrees, that would be a right angle. Right? You're subtracting it from 90, so it's a right angle triangle, and changing the result to nautical miles, we should be able to draw a circle of equal altitude around the GP. Okay, so here we are again. 3 circles of equal altitude, all created with right angle triangles. So this is from official navigation sources. Sorry, official celestial navigation sources. Okay, so his second claim is completely incorrect too. So Proto's first and second claims have been proven totally wrong. Claim 3, that a boat or ship's position at sea is not obtained via triangulation, but instead via trilateration. And he supports this once again with the claim that nowhere in any celestial navigation literature do they claim that they use triangulation. Now, rather than going into 50 million different things, this here is triangulation. They're using 3 right angled triangles, creating 3 circles of equal altitude. That is what they're doing. They triangulate their position. There is no triangles in trilateration. Trilateration is 3 straight lines, or 3 or more straight lines. Right? So the fact that Prototat is claiming trilateration means that he's claiming 3 or more straight, 2, 3 or more, whatever it is he wants to claim. Has to be more than one straight lines if he's claiming trilateration, which means he's claiming straight radii, right, that can travel for hundreds and thousands of miles from the observer to the GP of the celestial bodies. That means that is hundreds or thousands of miles of flat radii. Have to be straight, have to be flat. Trilateration is straight. The only difference between trilateration and triangulation, the main difference really is just that one uses angles to get the baseline distance, whereas trilateration is done signal to receiver, mostly. It creates the baseline without the triangle. That's the only difference. So prototad, if you're watching this, you're literally proving a flat plane by claiming trilateration. Claim 4, that right-angled triangles cannot be used to gain accurate distances across a flat horizontal plane and thus cannot be used for celestial navigation across a flat Earth, and he supports this claim with his own diagram and mathematics. Now, just before I move on to that, because that's going to be his main claim here, I just want to point out that I can get no end of sources that back me up, right, on this point, right, where no end of sources from celestial navigation that state they do triangulation. Well, I say no end, there's going to be an end to it, but I can get many citations that stated that they use triangulation, not trilateration. Not that it matters, because anyone claiming trilateration is claiming a flat Earth without even realizing it. So if you're on the opposition side and you're claiming trilateration, that's worse than claiming triangulation. I guarantee it. Not that it could really be worse, but it is. Just want to go here for a second, just to show, right, this is important, right? The co-altitude distance. This is the observer, this is the GP, right? This is the line of position, this is circle of equal altitude, right? This is the angle, so it's 60 degrees. That means there's 30 degrees of co-altitude distance. This distance is then brought down to the surface. So it's 30 degrees of co-altitude distance, and this 30 degrees then becomes 30 times 60 nautical miles. Right? That's 1800 nautical mile radius. That's the radius of the circle of equal altitude. So your nautical mile distance, which is subtracted from your altitude, you subtract your altitude to the celestial body from 90, right? This is important because this is important for what he's claiming, Prototat is claiming. So you subtract your altitude angle, right, to the celestial body from 90. In this case, he's come up with it's 60 here, so that's going to be 30 degrees, right, by 60 nautical miles, right? And that means that then is then transferred, right? Those 30 degrees are multiplied by 60 and transferred straight down, right, to become nautical miles, 1,800 nautical miles along the surface of Earth, right? And this is a 1,800 nautical mile radius. Radius lines are always straight. There is no such thing as a curved radius line, because a curved radius line will not give the full extent of the circle. So if you curve a radius line, then it's going to be, that line is actually longer, right? It's actually longer than the circle it will make. So that means that circle is not a circle of equal altitude. You can't have a curved radius line. All radii are straight lines. They have to be for to create even a circle, because that radii then becomes a diameter, right, which is another straight line. That gives you the full width of the circle. And then you can multiply the diameter by 3.14, right, if you want to find the circumference. But here it starts with a radii. So your co-altitude distance becomes your nautical mile radius. And that radius then gives you your circle of equal altitude. This is all flat. There is no curve that can be used or is possible within this system. This is a flat Earth system. End of story. But this is important. The co-altitude thing is the most important right here, because this is how they gain a distance, right? So that would be 30 degrees because it's a 60-degree angle, right? Right, subtracted from 90. So that would be 30 degrees. Now, claim 4. Read this one more time. Claim 4 from Prototad, that right-angled triangles cannot be used to gain accurate distances across a flat horizontal plane, and thus cannot be used for celestial navigation across a flat earth. And he supports this claim with his own diagram and mathematics. Now, I'm going to point some stuff out here. Right, I'm going to read out his first. He says here, if you double the complementary angle, and he calls this here the complementary angle, whereas often the complementary angle is called the depression angle up here, which would be the 50-degree one here and be the 25 one here. So 50 and 40 is 90, 25 and 65 is 90, right? But people do call this the complementary angle as well, right? Doesn't really matter, but he's saying that if you double the complementary angle, the distance to the GP more than doubles, right? He has it in black. Then in red he writes, 60 nautical miles per degree does not work on a right triangle. So he has down here a distance, right, here of what would be 3,000 miles, right? This would be 3,000 miles according to celestial navigation, and Prototad has it as 3,833.6 nautical miles. So according to celestial navigation, this distance would be 3,000 nautical miles, but Prototad has it down as 3,833.6 nautical miles, and he's stating that this proves that it doesn't work on a flat earth. Now, we really don't know how he's going to get these angles on a globe earth, and I really don't know why he's using angles if he says that they don't use triangles. He did say, he claims that the celestial navigation do not use right angled triangles, yet here he is using them, right? Now I'm going to show here now what he does and how he completely debunks his own claim. So first off, right, his first angle here, right, he takes a 65-degree angle to the star, right? That is an elevation angle. That is a celestial navigation elevation angle, right? Because he then has to subtract that from the 90, which leaves him with 25. So 25 nautical, so 25 by 60 is 1,500 nautical miles. Okay, so this here, this 1,500 nautical miles, that is a correct celestial navigation distance. This is done correct. The 25 is the subtraction that the 65 is subtracted from 90, which leaving you with 25. So that is a correct 1,500 nautical miles is a correct celestial navigation distance. As what he's using here is the co-altitude distance, right? The co-altitude distance will be 25 by 60, which would be 1,500 nautical miles. No problem there, right? That's correct. But then he takes another angle here, which will be 40, which is 40 degrees, right? Now, then he claims that this is 2,333.6 nautical miles, right? When it should be, because it's showing here 50 degrees, right? So this is a 40-degree angle. So it should just be another 1,500 to make 3,000 nautical miles, right? So how is he coming up with 2,333.6 nautical miles? Where is he getting this out of? Well, this is the trick. He's using this first correct celestial navigation distance angle, right? Right angle triangle. The thing he says they don't use, and the thing he says they can't use on a flat earth, right? First he says they don't use them, then he says they don't work on a flat earth to get the distance, right? But then he uses one right here. And then he takes another angle here. So this one is 65 degrees, which leaves you with 25 from the 90. Then he takes another angle here, which is 40 degrees, which should leave you 50 from 90. But what Prototad does then, right, is he then, right, uses the triangle here, right? He doesn't gain the second distance, right, using the celestial navigation way, which is to use it as 50 degrees of co-altitude distance that is then turned into nautical miles as a baseline. That's not what he does. What Prototad does at this point is he uses this original distance here with the 65-degree angle, but then he adds on to this by taking this angle here, this 40-degree right angle here, and he does terrestrial trigonometry, right? And what he's doing is pre-assuming that this star is 3,000 nautical miles high, because to do terrestrial trigonometry, you're using the internals of the triangle, whereas celestial navigation don't do that. They take an elevation angle. The height of the star is not known and is not involved in what they do. They only take an elevation angle to the star and then subtract that elevation angle from 90. So here, 65 is subtracted from 90, which gives you 25. Over here, it will be 40-degree angle subtracted from 90 will give you 50 degrees. But in his second angle, right, he ignores the celestial navigation process and moves to a terrestrial trigonometry process, right? So what he's actually doing here when he shows this 2333.6 nautical miles is he's actually lying, right? Because this is not a nautical mile distance. 1,500 nautical miles of it is, but the other part of it isn't, right? Because what he, if the full distance down here, 3,833.6 nautical miles he has down here. This is not correct. This is not a nautical mile distance, right? 3,833.6 nautical miles is not a nautical mile distance, because only 1,500 nautical miles of that is a nautical mile distance. The other distance here is not a nautical mile distance. This is a distance that's created by a pre-assumption that this star is 3,000 nautical miles high. Because to do trigonometry, he has to use a height. He has to take an actual height, right? Because I'm just going to show you something here. Where is it? Right. Here is, right, this is a right angle triangle. This is the hypotenuse, this is the opposite side, and this is the adjacent. This person here can do an angular size measurement on the Eiffel Tower, right? How can he or she do an angular size measurement on the Eiffel Tower? Because they know the height of the Eiffel Tower from the base to the top. So this person here can take an angle to the Eiffel Tower, and if the angle is whatever, 4 degrees, 24 degrees, whatever it is, right, they know, right, they don't subtract anything from 90, they just take that degree measurement, and they know, working off of the height of the known height, I should say, of the Eiffel Tower, along with their, right, that they can work out their distance from the Eiffel Tower, right, or they can work out the size of it in its angular size at that distance, blah, 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 blah. The point is, to do this, he or she here has to know the height of the object. This person here, this little person here, they know the height of the Eiffel Tower, so they can do an angular size measurement on that Eiffel Tower. They can use a trigonometric function to do that, right? But that's not how celestial navigation works, because the height of the star doesn't matter to celestial navigation. What matters is that the altitude angle to the star, right, and then subtracting that from 90. So instead of subtracting the 40 from 90, right, this is the first, right, ruse from Prototad. He didn't do that. He pre-assumed that this side here, the opposite, was 3,000 nautical miles high, and he used the trigonometric function to basically create a ruse, right? The second angle here, for a start, you don't take one angle and then another angle. You don't do that in celestial navigation. You take one angle, right? You get your radii, which would be here, which would be 1,500 nautical miles, and then you create a circle of equal altitude. Then you take another angle to a different star, let's say, and if it was a different star, it would be 40 degrees. Then he knows you would know that there is a 50 degree, right, 50 by 60, 50 degrees by 60 nautical mile baseline, which would be 3,000 nautical miles. You create a circle of equal altitude around that. So he should have two circles of equal altitude intersecting at a point, and then you would use a third one if you're at sea, or maybe a fourth one if you needed, but Normally just 2 to 3 can give them a fix, right? But the point is that he, Prototad, did not use celestial navigation for his 40-degree angle. The only part of that he did that was anyway connected to celestial navigation was using a right angle triangle, the very thing he said they don't use and you can't use on a flat plane. He used a right angle triangle, right, to get the angle. He used the 90, right, a right angle, to get the 40-degree angle. But then he cheated, right, and used a completely different process and function, right, for his second angle to get this 2333.6 nautical miles. That is not a nautical mile distance because he did not use the celestial navigation method, which gives you a nautical mile distance, right? It's a co-altitude distance that is that is turned into a nautical mile distance, a co-altitude distance between the two zeniths, between the star zenith and the zenith of the observer, right? That co-altitude distance in degrees is then turned into nautical miles on the surface of Earth, right? And it's all done with right angle triangles. So what he did here was he started off with a right angle triangle doing celestial navigation, then he done a switcheroo, right? Switched the briefcases, right? And he did a trigonometric function, right? Basically, he pre-assumed that this star here was 3,000 nautical miles high for his second angle. Then he claimed that this was a nautical mile distance, but it's not. It can't be a nautical mile distance because nautical mile distances are only created via celestial navigation processes, which is taking your elevation angle and subtracting it from 90. He did not do that in the second one. So there's 3833.6 nautical miles. Here is false. It is not a nautical mile distance. Only 1,500 nautical miles of that is real nautical miles. The rest is not. This 2333.6 nautical miles here is not a nautical mile distance. This is a surface distance made up from the trigonometric function, pre-assuming that this star is 3,000 nautical miles high because you're using the opposite here. Nowhere in celestial navigation do they claim a height to a star, to any star, or do they use the height. They just use the angle to the star, and then they subtract that angle from 90. That's what they do to create a straight line radius, right, or 3 straight line radii, and then 3 circles of equal latitude to give them to triangulate their position at sea. So what he did was completely false and it was completely dishonest. But I'm just going to show one last thing before I finish, and this is the most important part of this video. What Prototad actually does, right, is absolutely prove that celestial navigation do use right angle triangles and that they do definitely work on a flat Earth, because his first one, right, he used the exact process that they use, right, that he said they don't use, and he used the very thing that they said they don't use, that they do use, which is a right angle triangle. And he proved with his 65-degree angle here that by taking that from 90, he had 25 degrees, and he just did a co-altitude distance of 25 degrees and then multiplied that by 60 to give himself a baseline, a radii, right, of 1,500 nautical miles. So he's proving a flat Earth out and out here. He's proving all the claims he's making, he's proving that they're all false with this 165-degree angle, because he's proving that it does work, the process does work, and it can only work on a flat plane. He's proven they do use right angle triangles, and he's proving that it does work because he's showing it working right here with 1,500 nautical miles, the 25 depression angle that's left after the 65-degree elevation angle. So the fact that this first angle exists at all completely destroys his second angle claim. It destroys it completely, even though his second angle claim is not the celestial navigation process. It doesn't matter. His first angle disproves all his claims. And as I've shown already tonight, and I could show reference and citation and reference and citation and diagrams all from celestial navigation sources, completely disproving Prototad's and our opposition's claims. It's flat, right? Celestial navigation prove it, and they did prove it for hundreds of years. There's no way around it. So you'll have to just accept it, I'm afraid. Thanks for watching.